Let's see. So before lunch, we said we have a cone and water's coming out of the cone. V equals 1/3 pi r squared h. dv dt is negative 50 meters cubed per minute. Someone said what the radius was, what the height was, and I said let's hold off on that for right now. Let's actually go down to part 2 and take care of part 2. What are we looking for? Harmon. dHdt. I want to find dHdt. When do I want to do that? When do I want to find dHdt? When h equals 5. Okay, not feet. We are in meters. I want to find dHdt when h equals 5 meters. Okay. So before lunch, someone said, well, we know h, we know r. Good, we know that h is always 45 and we know that r is always 45 and h is always 6. Good? 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 H is always 6. So how's that going to work if we want to find dHdt when h is 5? What is always 6? What's happening here? Why do I have, like, Sabrina, tell me things. Aha. There's a container, and we have water inside the container. What shape is the water inside the container in? Don? It's a cone. I have a cone of water inside my conical container. Do I know the height of the container? What is the height of the container? Always. I keep mixing up the two. Yep, that is 6 meters, the height of the entire container. Do I know what the height of the water is always? No, that's going to be my variable. The height of the water is going to be h. Similarly, I know that the radius of the container, this picture is not drawn to scale, is 45 meters, but the radius of the cone of water is changing, so I'm going to make that a variable. Well, in the last problem, we had a way of relating the radius with the height. Did I tell you something like that here? I didn't. Kaylee, is that a hand? No. Okay. Here's what we're going to do. Let me draw a little cross-section of what's going on here. I've got my container, and I have my water. For the container, the height is 6 meters. The radius is 45 meters. For the water, the height is h, the radius is r. Oh, something great from geometry is about to come back. What do you know about these two triangles? They are not congruent. They are similar triangles. They all have the same angles. They both have a right angle. And while the angle at the bottom is the same, so the third angle has to be, they are similar. What's the point of similar triangles? What are you allowed to do? Okay, Don, redeem yourself. We can do things with ratios. The sides are not equal, but they are in a ratio. So I can set up a ratio basically to create something to relate the h and the r, which will then, in a couple steps, let me rewrite this formula in terms of just one variable instead of two. So there are a couple ways you could do this. I'm going to say h over r equals 6 over 45. You could say h over 6 equals r over 45. None of this matters because we're just going to solve for a variable anyhow. What variable do we want to solve for? Do we want to solve for h or do we want to solve for r? What? I feel like someone over there just said something. R. Why? Because we know things about h, so I want h's in my formula. Do some cross multiplying, solve this thing for r. I would recommend simplifying the fraction before you plug in. But then, plug in, and let's create a volume formula that just includes h's. Go through that work and see what you can do. You told me r, right? Okay. when you're done and have what I got for my formula, go through the rest of the work. Do the calculus part, do the plugging in. Things okay? Oh dear. Okay. By the way, the 5 minutes you missed was recorded, so there will be the video if you want to watch and hear the explanations, or see if you can figure things out. Negative 8 over 225 pi meters per minute at the end. I see some people still going, so keep going. Sit down. Yes. As I already mentioned, the homework will look very similar to specific problems in here, so definitely have your packet with you when you're going to do the homework, and if you're not sure where to go, find something in here that's very similar to things in the homework. There was somewhere I was going with this. Oh, so when we get to our test on related rates, there will be 6 problems. 2 of them will come from what we did yesterday and today. 2 of them will be area or volume problems. One will be probably pretty straightforward. The other one will probably look like number 5 or number 6 in the packet we just did, where I tell you that the height is related to the radius in a certain way, or I don't tell you that, but you have to realize that we're going to use some similar triangles to deal with things. Personally, I kind of like the similar triangle ones as a hint of what I might end up putting on the test that I haven't written yet. Okay, so any questions on anything from this problem? Thumbs up if you're feeling okay about related rates, to the side if you're iffy, down if we... Or just give me a look if it's thumbs down. Okay. Questions? You probably want to hear the beginning of this problem. Okay. That will be online by tonight. Questions on any related rate stuff? So I do want to start looking at the next topic, the next type of related rates problems. You won't have any of these tonight, but you will the following night. Turn the page. Number 7. Please read number 6 to yourself. So I'm not sure why I said number 7. Problem number 6. Read number 6. And that's all I want you to do. Any idea what would be a great place to start with something like this? Sabrina? Draw a picture of what's going on. We didn't really need those for the last couple problems. We're going to need a picture over here. So we have a camera mounted 3,000 feet from the base of a rocket launching pad. Okay, I'm going to be really boring, and I'm going to say that dot is my rocket launching pad. The rocket is going to rise vertically at a rate of 800 feet per second. Okay, so the rocket's going up. We have a camera mounted 3,000 feet away. Here's my camera. I'm just going to say that that's C. I want to find the rate that the camera to rocket distance is changing the instant the rocket is 4,000 feet above the launching pad. So, like this thing. Okay, so can you picture what's going on? Here's the launching pad, the rocket's going up, the camera's over here. As this happens, are all the sides of the triangle changing? Emily, which side is not changing? Yeah, that's staying 3,000 feet, so I'm just going to fill that in right now. Would you agree, though, that the other sides are changing? The height's changing, the distance is changing? I'm going to put some variables on these. I don't care. It doesn't really matter. What do you want to make the height? Okay, I guess that would make sense. I don't want to make the other one D for distance. I don't want D, T. That's just going to look weird. Come up with something. Z? I heard Z first. We're going with Z. If you want to make it X, you make it X. Okay. What rate were we told in this problem? dHdt, dZdt, or something else? Manoj, what is dHdt? Okay. Moving on, I know I don't have a formula yet. We'll get there in a moment. What are we looking for? Anyone besides Manoj? Casey? dZdt. When are we looking for that, Casey? Okay, I want to find dZdt when h equals 4,000 feet. So I need a formula. I probably should not have titled the section the way I did, because that kind of gives it away. Oh, what do you know? We are going to use the Pythagorean theorem here. Well, that looks like h squared plus 3,000 squared equals z squared. Or, if we want, we could say h squared plus 9 million equals z squared. That's the formula we're going to use. Well, continuing on, this is going to be exactly like how we were dealing with things. I'm going to find the derivative of both sides with respect to t. So h squared plus, I'll go with the original 3,000 squared equals z squared. What is the derivative of h squared? Just say it. It's not just dh dt. 2h dh dt. I didn't hear the 2h part. What is the derivative of 3,000 squared? Why 0? Why not like 2 times 3,000? It's a constant. Doesn't matter how you write the constant. If you write it as the 9 million or the 3,000 squared, it's just 0. Derivative of z squared. Now, if instead you made it x, and we said x squared, what would the derivative be? Yeah, you are still getting dx dt. I know that kind of looks weird because when we did our implicit differentiation, x was like the independent variable. What is the independent variable here? What's everything based on? What variable is everything? What was that? When we were dealing with our implicit differentiation with the x's and y's, we said that all the y's were really functions of x. Sabrina? Say it again. Yeah, everything is really a function of time. T is our independent variable. Since we don't have that anywhere, everything is going to get a d something dt. Well, we know that dh dt is 800, so I'm going to plug that in. And we're going to get 1600h equals 2z dz dt. Part 4, we're going to go plug in our h equals 4,000. And we're going to solve for dz dt. Oh. Do you see the problem that I'm seeing? Huh. I want to find dz dt. I know my h, but I've got that z left in there. Thoughts? So I'm dealing with my specific instant when the height is 4,000 feet. Casey, is that a hand? Couldn't we figure out the z at the specific instant when the height is 4,000 feet? Can't we just use Pythagorean theorem? We are going to use actually, I'm going to cheat a little bit on this one. We're going to use Pythagorean theorem to find z at our specific instant, where we have 3,000 over here and 4,000 over here. I'm not actually going to use Pythagorean theorem. I'm going to cheat. What's the hypotenuse going to have to be? Remember, like that 3, 4, 5 special right triangle? If you don't remember that, use Pythagorean theorem. That'll work too. But now we have the z. This is really the extra piece with the Pythagorean theorem problems. I'm just going to tell you one side. You have to find the other. That's not the hardest thing in the world. So we're going to get 1,600 times 4,000 equals 2 times 5,000 dz dt. Go and solve for dz dt. I think it should actually be nice-ish. Well, like no decimals. Sanjana?
640?
Yeah. And what about the units on that? What is z in the problem? Manoj, what's z? Well, yes, that's the units. Z is this distance over here. So how's the distance changing? In feet, because that was our other length measurement per second. 640 feet per second. Done. For this, is that okay? With the 9 million, okay. But like the 3,000, I don't think 3,000 is. Yeah, you can. I think in general it's going to be more cumbersome than it's worth, but your call. Number 8. Every single calculus book I have ever, not number 8, number 7, sorry, my numbers are different than yours. Every single calculus book I've ever seen includes problems like number 7, because apparently this is a very realistic application of ladders sliding down walls. I can't explain why they all include it, but they all include it, so we should see how to do this. I would like you to read, and that's it. Just read. I drew my wall. I'm going to put the ladder over here. Here's like the floor. And you see that it makes a triangle. And can you envision what this is going to look like as the ladder slides down the wall? Can you kind of picture the triangle? Okay. Quasi.
Is it the top of the ladder that's sliding down the wall? Like, is it going that way or is it going that way?
Do that one more time.
Is it going that way or is it going that way?
Here's the ladder.
Uh-huh.
The top is sliding down the wall. So it's going to start
that
looking
Okay.
like that. Wait, were you basically showing the ladder was going to... No, that's not what sliding down the wall means. Oh, okay, we've cleared that one up. So, are all three sides of the triangle going to change as the ladder slides down the wall? Emily, what's not going to change? The ladder is still going to be 30 feet long. That's not changing. I might as well go fill that in. How about the other two sides? Are they changing? If you're not sure what to do when you're labeling things, ask yourself, is that side changing? If it is, it needs to be a variable. If it's not changing, we're going to leave it as a constant. So I've got that constant for the hypotenuse because that's not changing, but since the other two sides are, we'll make them variables. Since it's like Pythagorean theorem, maybe just like A and B for the two sides. Doesn't matter what you call them. I'd like you to do the rest of part 1 and 2. Set up the formula, tell me what rate you're given, figure out what rate we're looking for, and at what particular instance. While you do this, I'm going to pass out next week's cumulative review. Don't forget that you have one due tomorrow. Please do not hand this one in tomorrow in place of the one that's actually due tomorrow. That's why I put the dates on the top. You're welcome to everyone listening to that. And again, what we're doing right now will not be on tonight's homework. No Pythagorean theorem stuff yet. By the way, I'm not passing out the other worksheet part of the homework because that's the same one you had due 2 days ago, where I told you only do the first 2 problems. There are a bunch of others that we'll do other times. You can do a couple more of those to get a little more practice with the implicit stuff. Bless you. If you labeled the triangle the way I did, with the height as h and the base as b, what rate are we given? Quasi. Okay. Nope, that's not right. 3 feet per second. Is dB dt positive or is it negative? Sabrina. Why? What we're always going to... Say that again? Then wouldn't that make it negative? Okay. We're always going to ask ourselves, what are we doing to that like dimension or side or whatever? We are increasing this length as we pull out the base of the ladder. So that's going to be a positive thing because we're increasing that side. By the way, as that happens, what's going to happen with A? Will that increase or decrease? Decrease. So when we're done, hopefully all the math will take care of itself and give us a negative answer for dAdt. Part 2. We are trying to find dAdt. In particular, when what is 8? You know what? Cross out the second question. We don't have time for one. That's fine. You would just plug in new things at the end. I want to do this when b equals 8 feet. Please take care of part 3. Don't go on to 4 because it just gets a little bit messy and I want to deal with the messy things. They're not all nice 3, 4, 5 right triangles. Two AD ADT plus 2B DB dt equals 900. Good. What's wrong, Sabrina? 0. I see so much of that on like tests and quizzes on this stuff. No, derivative of a constant is just 0. Actually make it 0. dB dt is 3, so I can say 2a dA dt plus 6b equals 0. When b equals 8 feet, we should find the a. We're going to get a squared plus 64 equals 900. A squared is going to equal 836. You're either going to give me an exact final answer or you're going to give me a decimal final answer. Either one would be okay. I think I'm just going to say square root of 836. I could break that down into 4 times 209, so I can say 2 times the square root of 209. Quasi?
During the AP exam, if we give in decimals, is it always 3
If it's,
decimals?
yes, always the final answer accurate to 3. So I would not get a decimal here rounded to 3 places, then plug it in because that might throw off the final, which that happened to some of you on the last test. Give many more places or store it in the calculator. We'll talk about that on a future day. And then use that thing. So I'm going to deal with that. And I either have, no, I do have 1 more minute. We're going to get, oh, actually, you know what? I don't need to simplify that because wait, hold on. Never mind. 2 times 2 root 209 dA dt plus 6 times 8 equals 0. 4 root 209 dA dt equals negative 48. We'll divide dA dt equals negative 48 over 4 root 209. We could simplify, or we could just go to the calculator. I'm thinking negative 0.830 is a decimal feet per second. I just want you to see how we can deal with these roots in there, and decimals will be okay. As long as it's a decimal, that is accurate to 3 places. And you know what? If you're not sold on that, give it to 4 or 5, and you'll be safe. None of this tonight. We will do more Pythagorean theorem and then 2 other variations on Monday. And we're going to shut off this recording now.